So now that you know a little bit about threads and tasks and parallel processing, we are going to take a look at asynchronous operations. And in particular, we're going to be looking at the async and await operators. Uh, they're considered code markers. And in applications that you will be using in the future, that interface with database applications, you will actually see these code markers in quite a bit of the generated code. When we get into MVC and Razor pages, the system will generate some code for us. And in the generated code that interfaces with the database, you will see these operators. So it is important that you understand what they are doing and that you are able to actually utilize them in your own code. So I think we already kind of know why asynchronous processing is popular. Uh, it's because your program can work on other tasks while it is processing or waiting on a task that takes longer. With synchronous, if you had two methods that were not dependent on each other, uh, they're going to run in order. So if method one takes a long time, method two just has to sit and wait. Okay? And that's the problem with synchronous processing. With asynchronous, if the methods are not dependent on each other, then we can actually have them run at the same time. So to utilize asynchronous processing, there's actually two keywords that you need to add to your code. One is async, short for asynchronous, and the other one is await. So any method that you are going to add await to has to be asynchronous. They go together. So if you're going to use the await keyword, then you also have to use the async keyword. Adding await to a command prevents you from blocking the thread so that it can be actually used for other things if you're in a hold state or a wait state. So I do have a couple examples that we're going to look through. They start as a synchronous program, and then we're going to convert them to asynchronous. And so the first one is a breakfast program. And so you can see we've got some do nothing classes. They're intentionally empty. And then in our main program, we go about the business of making our breakfast. Okay, so we create these little class objects and we end up calling some methods here. So we have methods that make toast and we got methods that make juice. And you will notice that in some of the methods, we actually have a delay. So, if you're actually going to make toast, there is a delay between when you put the toast in the toaster and when it's ready to remove. Same with, bacon and eggs. You're going to have some delays there. So we've kind of built those delays into this program. Okay. And we'll go ahead and run it. Okay, so you can see our built-in delays are working. And that's where the pauses are coming from. Okay, so that is the program. And right now, it is running synchronously. So it just kind of runs everything in order. And if there's a delay, too bad, everything else has to wait. Okay, and we are going to convert this over to asynchronous. So in order to do that, the different methods that have the delays, we are going to make those asynchronous methods. Okay, and then we're going to add await um, where appropriate. So for the first one, for toasting bread, right? We can't put butter and jam on the bread until we have toast. So await makes sense there. So we add it, you know, to toast bread. And then you'll notice that because we have a wait here, we have to make this method asynchronous. And then it is expecting us to return a task. And the data type for the task is our class, which is toast. Okay? And then you'll notice because we have async here, we have added it to the end of the method. That is a convention in C# that we will be following. The other methods that we need to adjust are the other ones that have some delays. Okay, so we add await. And then because we have kind of added that, we have to then add async to the method signature. Okay, and so basically this is just saying that, well, we can't really flip the bacon until we've cooked the first side, so there's an await there. And then while we're cooking the second side, we have an await there, and then we can put it on the plate. Okay, and then you'll notice we've kind of done something similar with the eggs. So these are the different methods that we've added async to. And so here in our main method, we've added await to fry eggs and an await on the bacon. Basically, they're using the same pan, or we're pretending they are. And then we've also done an await on the make toast with butter and jam. Okay, so because we've added these, we have to add a sync to main, and then it's going to return task. So prior to that, it was void. So you do have to change your signature here for main. Okay, so this is the fully converted program. We still have our do nothing classes, but now we have added async and await. Hopefully I didn't copy too much. Okay, and you'll notice that not all of the methods are asynchronous, right? If they don't need to be, we are not going to make them asynchronous. And you should notice that it is running a little bit faster. Okay, so making it asynchronous did make it run a little bit faster. And I do have another example here for you. This is a school day, and actually in this one, I went ahead and added a stopwatch so you could actually check the time and verify that it is a little faster. So in this school example, the first one is synchronous, which means that the different methods have to wait for the previous one to finish. And we're just pretty much operating on the main thread here. And we've got a little stopwatch that we've started and stopped so we can print out the milliseconds that this takes to run. And so there's a delay at the beginning because we're waiting for school to start. Okay, and then once school starts, we can go to programming class and calc, and you can see that was about 13 seconds. Now to convert this one over, we're using a little different technique because there is more than one way you can do this. In the main method, nothing changes because we're calling a demo method where most of the work is done. So this kind of avoids having to change the signature for main. So down here in our demo method, you can see that it's asynchronous, and we are not dealing with classes here. So we don't have to worry about returning, a task object or anything like that. There is no classes involved in this program. And so in demo, we basically start our stopwatch. We create 3 different tasks, and we associate those with the methods. After task 1 starts, we do wait. And that's because task 1 was the beginning of school. So we're going to wait until school starts, and then we can attend our classes. And we're not going to finish until all of the tasks are done. Okay, so that was added as well. And then for each of the tasks, okay, we actually coded up a lambda expression that's going to run the task. Okay, so you can see we've got 3 tasks, and they look, what the tasks do are the same as before. We've just put them inside the lambda that's actually going to run the task. Okay, and then we had to make each one of these asynchronous. Okay, and you'll see that it is returning a task object in each of these cases. Okay, now this one runs faster. You can see looking at the milliseconds. The other one was, I think, 13 seconds, and this is 11. So, there's not a whole lot to this program, so that's a pretty big difference. 1,300 or 13,000 milliseconds versus 11,000 milliseconds. Fairly big difference for a short program like this. Okay, and so, if you want to see how this one runs, you certainly can copy it. Pull it over here. That initial delay is going to be the same in both programs. And that is because we are waiting for school to start. Okay, but then you should notice the rest runs a little bit quicker. Now, if we didn't wait for school to start, this would run a whole lot faster. Okay, but you can see that you actually went to class before school started. So having the await in there makes sense. So a couple different ways that you can convert your programs to utilize asynchronous programming. What we haven't taken a look at is exceptions yet. And so what we're going to do is we're going to modify the little asynchronous breakfast program, and we are going to add exception handling to that. In any asynchronous program, if an exception is thrown, it is actually stored in the task. And that is because in an asynchronous program, you could have, multiple threads running. So you could actually get more than one exception. And so it's stored in the task, uh, and it is considered a system aggregate exception. Okay, and it's added to the aggregate exception inner exceptions collection. Now, when the exception is thrown, what's weird is that, especially if you look in your program and you can see the exception, it's not going to say aggregate exception because after the exception is thrown and it's stored as an aggregate exception, the original type of exception is a rethrown. So you're going to see that original exception in your program instead of an aggregate exception. Okay, so this kind of storing it as an aggregate exception in the inner exception collection, that's all happening behind the scenes. So here is our modified program for exception handling, which I'm going to copy and paste, and then we'll take a little closer look at it. All right, so should be familiar what all these little methods are doing because we've looked at it already. And where the exception handling it is around basically the calls to these methods. So we've got our try around all of the methods. And then we've got a couple of catch blocks. Invalid operation exception is an exception that we are throwing in the different methods. And then the exception here is just the generic one to handle everything else. So where are we throwing exceptions? Well, you can see I've kind of commented it out, but we will go ahead and take the comments out. Okay, so in this little exception scenario, our orange juice container fell and all of the orange juice spilled, which is really a bummer if you like orange juice. Now, orange juice happens to be the last thing in our little list. Okay, oops, we have two exceptions. We got the toaster on fire too. So as we're going through here, looks like I didn't comment that one out. So here we've got our poor little toasters on fire, and that exception occurred first. Okay, so let's go comment out the toaster fire. There it is. Okay. And then we'll run it again so you can see the spilled orange juice. We're not having a good morning. Yep, after the toaster fire and the spilled orange juice, we're just going to go out for breakfast. Okay, so that's just kind of simulating the exceptions. And you can see that they are handled up here. So hopefully this has given you an idea of how you can convert your programs over to use async and await. And when you encounter that code in future classes, okay, a lot of the frameworks are using it, you will understand what it is doing.